we are going to do another experiment, that is study of microstructure of annealed mild steel samples. So microstructure you know, and annealed mild steel you know, and anneal is, it is a quenching method. That sample which is quenched or which is cold inside the furnace. That means the slowest cooling of the sample is called annealed mild steel sample. So for microstructure study, after annealing, we have to do some polish, and we need one mirror finish surface. For that surface, we have to polish our sample. For polishing, we have different method, or we have to use different emery paper, velvet cloth, that means fine micro cloth, and we have to use different liquids like alumina powder, diamond paste, this type of things. So for that we have to go our polishing machine. Let's go to the polishing machine and we will polish our sample. So this is polishing machine. Here we can polish our samples. So one process is there. So first we have to use one rough paper, that may be emery number 320. So this is our emery 320. Here we have to polish like this way, and after that we have to change this polishing paper. Again we have to add another one, that is 400. After 10 to 20 minutes polishing on 400, then we have to change it 600 grade, and after that we have to use 800, then 1000, then 1500. After that we have to use micro cloth. That means in normal word we can use velvet cloth. On velvet cloth we can use alumina powder, then diamond paste. After that we have to do one etching process. That is on chemical process. For mild steel we have to use nitrile. That is the mixture of nitric acid and ethanol. And we have to swap on that solution for 15 to 20 seconds. And nitrile ratio of nitric acid, that is nitric acid percentage is 3 to 5%, and rest of is 97 to 95% is ethanol. So after polishing we have to dry the sample, then we have to etch it in nitrile solution, and after that our sample is ready to see the microstructure. Now our sample is ready. After doing this is fully shining, and now we are going to study the microstructure in our microscope. So now we are coming to see the microstructure of this sample. So we placed on the sample holder under the microscope, and this is our microscope. So and now we are using this objective. This is 20x objective, and we are using one Exovision's SC64 software. Or in this software, just we can go live mode. This is live mode, and this is things. And if we click the live mode, then picture will come directly, and this is coming, and this is the microstructure of this sample, annealed mild sample. This is the grain. Here you can see this is one grains, and this is another grains. This is 1 grains. It's called grains. So how many numbers of grains are there, and what is the percentage of the numbers? We have to count it, and average grain size we have to measure for this snap or this area. So for that there are two methods. One is line intercept method, another is comparison methods. So we are going to use line intercept method. So for that we have go to one, you see, measure one length we have to take, length 1. So just draw a line, maximum length, or cover from first point to last point like this, and its length is showing 617.67 micrometer. So another line, we have to draw maximum line. Again we will draw some line. So draw maximum line. Line may be horizontal, vertical, inclined. There is no problem. We can draw any, but it should be straight. Now I have drawn 1, 2, 3, 4, 5, 6 lines. So you see, length of the lines is, first one is 617.67 micron, second one is 619.28 micron, third one is 615.35 micron, fourth one is 615.26 micron, next one is 617.7 micron, and the last one is 618.47 microns. So this is the length of the line, and we have to calculate, or we have to see how many length, how many number of grains it intersect. So first line, you see, this is 1 grain, this is 1 grain, this is another grain. So if you count it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 or 20. So first line intersects 20 lines, 20 grains. So second line we can calculate, we can count 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So next one is intersect with 20 grains. So for every line we have to count how many grains it intersect, and then we have to do one formula with that one, that is grain size is L by N. L means length of the line, N is number of grain intersect by the line. So for the first line, if we calculate, then L means that is length of the line 617.67, and length of the line should be converted into mm, that is millimeter. 617.67 divided by number of grains, that means 20. 617.67 divided by 20 into just converted into mm. Then for the second line also, its length of the line is 619.28 micron and divided by 20. For the third one also, just count the number of grains and then multiply and divided by number of grains, and the length of the line is 615. So that's why you count all the grains or intersect grains, then L by N, just use L by N, then average of L1, L2, that is line 1, line 2, line 3, line 4, line 5, line 6. So that just count L1 plus L2, L3 divided by 6. That is the average grain size diameter. So for mild steel, it will come about 22 point something, and its grain size will be 7 or 8. Okay, thank you. So you have to write experiment number 2, then title study of the microstructure of annealed mild steel sample, then objective line intercept method or image analysis method, then procedure what is line intercept method and what is structure comparison method. So in short, you have to write like this, or you can directly copy this to method. After that, you have to attach that picture. There will be two picture. One is fresh grain size picture and then line intercept method. After lining, then you have to take snap and you have to attach with this left sheet. And then normal calculation also you can see. So this is the line intercept method calculation formula. You see, mean linear intercept method, that means line intercept method. This is it showing, and this is the formula: d bar equal to L by N, where L is the length of the linear line in mm, and N is number of grains, boundaries or grains. So assuming reasonable shape for this grains and obtain a mean in diameter of the rotation, then capital D bar 1.75 D, and where D is average grain diameter in mm, and also dm or this thing is not required. Up to average diameter you have to put, then mean what you get diameter, then you have to multiply that one 1.75, then you will get capital D or average grain diameter. So up to that level you can write this one, and using this formula you will make this one. So another thing you can write about the comparison method using image analysis method or software. You can write the software name using we got this result like this. You can, after writing this, you can attach to your picture. So this is how you have to make your lab reports. So we will send you this manual. After that you have to submit your report. Okay, thank you.